Hello students, in this video we will be reviewing the lesson 3-7 congruent triangles by angle side angle, angle side, and hypotenuse leg theorem. Let's go ahead and begin in the do now problem. It says, use the picture below to find the value of x. Notice that we're giving the three interior angles of a triangle. So we need to be able to recall the triangle angle sum theorem. That theorem states that when you add the three interior angles of a triangle, their sum is equal to 180 degrees. So let's set up the equation. 3x minus 4 plus 9x plus 17 plus 6x minus 31 equals 180 degrees. In order for us to isolate x, we need to combine the like terms. So let's group all the x terms. 3x plus 9x, that gives me 12x plus 6x is 18x. Then let's combine all the constant numbers. Negative 4 plus 13 plus 17 gives me positive 13. 13 minus 31 is going to give me negative 18. Notice that our equation has been simplified to a two-step equation. So what we need to do here is we need to add 18 on both sides. And we get 18x equals 198. Then we divide by 18 and we find that x is equal to 11. So since it was only asking us for the value of x, we have found the answer. All right, the objective for today. Students will be able to prove the two triangles are congruent by angle, side angle, angle side, and hypotenuse leg. So previously, guys, on the last class Friday, we covered the first two shortcuts. Those were side, and side angle side. Again, I told you that it's super important that you understand that the angle must be the included angle in order for you to use the shortcut side angle side. Today we are learning angle side angle side, and the hypotenuse leg theorem. Remember that the two that do not work is angle, and the donkey theorem, ASS, which in this case is not a good word, so I'm going to go ahead and switch it, right? So those two don't work, okay? All right, so let's go ahead and review the first shortcut, the third shortcut actually, because we learned the first two on Friday, and today we're learning these three. So the first one is angle side angle. So it says here, if two angles and the included side, the one that is in between the two given angles, of one triangle, so again, we need two angles, okay? So here, these are the two angles. And the included side, so we need the included side must be the one in between the two given angles. Okay, so if we have a triangle, and its two angles and the included side are congruent to the corresponding angles inside of another triangle, then the triangles will be congruent. So this would be angle, and side. When I read the shortcut, I notice that these triangles are congruent by angle, side angle. Looking at the next shortcut, angle, side. If two angles and the non-included side of one triangle. So we have two angles here. And the non-included side, this could be a side that is not in between those two angles. So I'm going to go ahead and label this triangle. So here we have angle, and then we have the side. Notice that when I follow the pattern, I go angle, side. because in this case, we need the non-included side. So angle, side. So it says here, if two angles and the non-included side of one triangle are equal to the corresponding angles and the side of another triangle, then the triangles will be congruent. And then this last one, which is the HL, which is the hypotenuse and the leg of the right triangle. So this only works for right triangle, the HL theorem. So it says, as long as you have the hypotenuse of right triangles congruent to each other and at least one of the legs congruent to each other, then you can conclude that the triangles will be equal. So we just need the leg and we need the hypotenuse to be congruent. But again, this only works for right triangles. Super important that you know that. Okay, so because we have the hypotenuse that are equal and at least one pair of legs that are equal, then these triangles are congruent by HL, hypotenuse leg theorem. Right, let's go ahead and do some practice problems. But before we do that, I just want to remind you of ways that you can find an extra pair of angles and sides. So remember, when we have that reflexive property, when we have the definition of a midpoint, and then when it's given, when the ticks are marked. For angles, we're going to cover all of the angles that we should already know from Unit 1 and 2. If you recognize an angle, then you can come back and put the hooks. Don't ever assume. You need to make sure that you justify you coming back into the diagram and adding those markings. All right, let's go ahead and look at the practice problems. Notice that these triangles are right triangles, right? These are right triangles. So I can go ahead and check for HL. So looking at these triangles, are my hypotenuse congruent? And the answer is yes, because the hypotenuse are the sides that are opposite the right angle. So in this case, both of my hypotenuse are congruent. I also notice that we have a leg that is being shared. And due to the reflexive property here that states that a side is equal to itself, we have the pair of legs that we're looking for. So what can you conclude about these two triangles that are sharing a side? That the triangles are congruent, not just because they look the same, but because of the HL theorem. Okay. Looking at the next one, I have a pair of angles that are equal because both of these have one hook. Have another pair of angles because those two have two pairs of hooks, or a pair of hooks. And then we have this side that, because if we recall the reflexive property stating that one side is equal to itself, right, that's going to give us a pair of sides. So when I want to name the shortcut, I just follow the order. This is angle, side angle, and I just look at one triangle. So the triangles are congruent by angle, side angle. All right, let's look at the next one. We have a pair of angles. We have a pair of sides. And then, if you're smart enough, you should already recognize that these are vertical angles. Very good. Those of you guys who identify that from Unit 1. And I can come back and add those hooks because I recognize that these are vertical angles, and that's going to give me an extra pair of angles. So when I follow the order to determine what shortcut is the one that I will be using, I follow the order angle, angle, side. So the triangles are congruent by angle, angle, side. If you're probably thinking, well, why, Ms. Hernandez? Why can't I just go side, angle, angle? Well, if you say side, angle, angle, notice that that's not one of the shortcuts, so you have to go the other way, okay? As long as you don't get the angle, 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 or the Dunki theorem, then you should be fine. All right, looking at the next one, we have a pair of angles, we have a pair of sides, and then once again, we recognize those vertical angles. So I can come back and add an A. And so when I look at one triangle to determine the shortcut, I go angle, side, angle. So what I can conclude here is that the triangles are congruent by angle, side angle. All right, let's look at the next one. It says, for what values of x and y are the triangles congruent by the HL theorem? So the HL theorem states three conditions, right? These must be right triangles. Second condition, hypotenuse are equal. And at least one pair of legs are equal. So I need to know that my hypotenuse need to be equal to each other. So I need to set those two equal to each other so that I can know the value that x needs to be in order for these triangles to be congruent by HL. So I move the smallest x term. We get x plus 1 equals 3 minus 1, and we get x equals 2. So these two hypotenuses will only be equal when x is equals to 2. If x has a different value, then these two hypotenuses would not be equal, and therefore you cannot conclude that these triangles will be congruent by HL. Right. So what would be the value of y so that these triangles are congruent? So we do x plus y equals 3x minus 3y. Notice that we're dealing with an equation that has two different variables. So since we already found the value for x, we need to come back and substitute so that we can then solve for y. So this is 2 plus y equals 6 minus 3y. And then we combine the y terms. So this is 4y, negative 4y. 2 equals 6 minus 4y. Then subtract 6 and you get negative 4 equals negative 4y. Divide by negative 4 and y equals positive 1. So only when x is equals to 2 and y is equals to 1, the hypotenuse and at least one pair of legs will be congruent. We already know that these are right triangle, and that's the only way we can say that these triangles are congruent by the HL theorem. All right. So you would be responsible of completing your independent practice. There's 8 problems of the theorems, the shortcuts. And then I'm giving you again a review because we're taking the exam pretty soon of lesson 3-2 and 3-1. It's with the interior angles. Remember, they're equals to 180. And then the exterior equals to the sum of the two remote interior angles. And then on this one, make sure you know you have to use the distance formula. So that you can come back and find the lengths of this triangle, QRT, and then you can classify it. Thank you so much for watching these videos.